Hello. So I'm going to continue with our work on growth mixture modeling or latent variable mixture modeling. And again, I'm focusing on examples using longitudinal data analysis. So, but you can do the same with cross-sectional data. So in this example, I'm going to run a growth mixture model for a smoking variable that has a number of categories, and I can't remember exactly how many categories, could be 4 or 5, but I'll see in a second once I run this. Anytime I run an analysis with a it's based on a growth curve model, I'll first run the growth curve model, see what the best model that fits the data. So in this case, I have smoking measured at 4 different time points. This is a combustible cigarette smoking measured at 4 different time points. So everything is the same as we did for the growth curve model and for the growth mixture model, the latent variable mixture. We could actually call it growth mixture model when it's based on a growth curve. So I'm using this essentially the same. Well, this is the same file that I used the other day, but this is the same setup I had for the uh, growth curve model with the continuous dependent variable. The only difference now is that I have a categorical dependent variable, and I'm going to declare that these variables are categorical. So I have smoke one, smoke two, smoke three, smoke four. So I say we'll contract this here to be smoke one through smoke four, which is something nice that Mplus allows you to do. And then we have 4 categorical variables or dependent variables. Again, you only declare the dependent variables. And then we're hypothesizing a linear trend, a linear trend, right? So we have baseline and slope, intercept and slope, right? And then they're linear, so we go and equally spaced time points. So 0 to 1, 2, 3 for the 4 time points, where 0 indicates that time point 1 is the intercept value. So we're going to go ahead and run this and take a look at its fit to the data. Okay, and again, we have 1837 values. We have the estimator that is used for weighted least squares estimator that's used for categorical outcomes. And yes, it's 4 categories. So it's like never smoker, experimenter, weekly smoker, daily smoker, as far as I remember. And these were, again, combustible cigarettes. And this is the change over time. You can see that there was some decrease in the never smokers over time. More daily smokers. So essentially the same amount, but there was more change in like the lower levels, some of the lower levels. Again, the sample size decreased as far as I remember over time. You can see that in the covariance coverage. There was some decrease between time 1 and time 4, or it wasn't a horrible amount of decrease. And then we use this expect we use this the all available data when we're dealing with with estimating these parameters, right? So you don't need to have complete data, right? It's full information maximum likelihood method. And you get the thresholds here. So it's a lot of what we've seen before, because I actually did show you a growth curve model before, and we see this linear model fits the data really well. All these parameters look very nice. All these statistics look nice. So we say, okay, let's go ahead and work with this one. This will be the input for our growth mixture model. So let's see, this is the growth curve model. So we can get rid of that. Be a little more parsimonious here. And now we're going to run the mixture model. So everything else is exactly the same as before, except for now we have a categorical variable. Sometimes this can cause issues, just for your information, especially if you start freeing variances and things like that. It could become a little bit more complicated. So right now it's fine because it's a very simple model. No predictors or anything. And let's see what we get here. So we get our log likelihood values. BIC value, right? And two classes. One class is relatively small, which is interesting, right? So it's below that 10% threshold, right? So of course this can change too. Like maybe if I do I oops, I didn't actually add any predictors yet. So I can add predictors to this model. So maybe I'll add, and at this time I'm just going to stick with this two class model. Let me just add some predictors. Yes. Well, we can say oh, how about free or low cost lunch? Sensation seeking. Let's look at sensation seeking as a possible predictor of smoking. All right, so we'll put that over here. All right, and then we'll actually start with a class C on S. We'll do that first. And then we'll allow we'll look within the classes themselves. Okay, so let's just run this model now. A sensation seeking predict smoking, and there's some problems here. What does it say? Set up produce a syntax warning. So I messed up somewhere. C on I. Oh, duh. I'm not even. I hope somebody caught me doing this. I was wrong. Set sensation. All right. That's better. It's still slowing down a little. You can tell. It has to do a little more work. And so we just, run this so we can see what's going on here. And all right, so we see, so it's just kind of almost reversed a little bit, the ordering of the classes. And is there an effect? So there is a significant effect. That's one thing, but can we do it in odds ratios, latent class odds ratios, logistic regression odds ratios? Okay, so have higher sensation seeking but this odds ratio decreased the odds of being in class one versus class two by about 14.3%, right? Which makes sense because I think the class is reversed, right? Right. Class two became the smoking class. You can tell that the class is probably the one that's smoking more, right, than the other. So look at the means for the classes. Class one doesn't really show us anything here. And so this is much more negative class. So class one is a lower smoking group. Okay, so if we were to free the variances, I will actually go in within the class IS on sensation. So this alone will just say that we're regressing the intercept and the slope on this, in addition to using it as a predictor. So you see how things are starting to slow down because when we're dealing with categorical variables, so it's going to take a while to run with 100 replications, right? So that's when you start working with categorical variables, a lot slows down. There's a lot more calculating to be done here. Good sleep. Wake me up when it's done. This is only with 100 replications. Imagine doing like several thousand of these, right? Becomes more complicated. Just takes a little bit more time. But we're only doing 100. Computer's getting its exercise and it likes doing these. And we don't even know if it's going to solve or what. We'll see what happens. And log like, okay, so again, everything worked out okay. Not much change in the classes, which I like. I don't want to see that happening. We still have really nice values for entropy, nice values for the posterior probabilities. We see sensation seeking has no effect on baseline or trend value for smoking, but it does. Does it distinguish the classes like it did before? And it looks like yes, it does. Okay, so we can again look at the odds ratios. Where were they? Here it is right here. Well, this is class one, so it's about the same as it was before. Like about 12.1% here. Then, of course, you could do many more things. Like we can release, like we can vary this by class, right? So we had, I think we did this the other day, right? C number one, C number two. Then we can vary this by class, right? So again, I don't put anything under class number one because that's assumed to be the same as the population. Then I put it to vary. So let's say there's well, allowing the effect of sensation seeking on baseline and trend to differ by class. Let's go ahead and run this. This might take a while, so if it's too long, I'll just stop that and well, maybe it's even better. Well, okay, let's see. Come on. Let's see. It's like being at a casino, right? I just pulled something. Here's the numbers showing that I'm going to win a bunch of money. There you go. Come on. Stop right here. Let's see what's going on. Right? What do we get here? Does it, again, I don't know what the fate is. Okay. So that still worked. And we were able to vary them. And let's see. The classes remain the same. Yes, pretty much. So, okay. So there's no effect in class one. Ooh, look at that. No, that's nothing. No effect in either class. Wait, is it? And in class two, no effect in class two, and no effect in class. So it really didn't make any difference there, right? And we still have the between factor. So that's all I'm doing. And if I want, I could try to see if we what would happen if we released a variance in one of the groups. Of course, I could add more classes, but that's working with a categorical variable. In this case, the dependent variable is ordinal, right? Because there's four levels, so we're assuming that we have the sum proportional odds. We have proportional odds, so the odds are the same going class one to class two to class three to class. I mean, sorry, no. Yes, it's across the classes. Levels of smoking, right? They remain equal going across the levels. So from level one to level two, two to three, three to four, right? Not from from a non-smoker to a experimenter, etc. So we have that proportional odds assumption, and assuming that's correct, we can use this model. The other thing is that you have to remember is that the latent variables are continuous despite the variables being categorical. So you can't do anything with reporting the effects of sensation seeking as an odds ratio or something like that. You have to, it's still just a effect on a continuous variable. And if you want that other kind of interpretation, you can use GEE. All right. Okay, thank you very much. This is practice, just practice, play around with this stuff. It's all available to you. Thank you. Bye.